Good evening, students. Today we are going to see what is mesh analysis and how it can be used to find various currents flowing through a circuit branch. So the problem given is in the circuit shown in figure, determine all branch currents and voltage across 5 ohm resistor by loop analysis. Mesh analysis is also called as loop analysis. So this is the given circuit. In the circuit, you can find there are two independent loops. This is one loop and this is another loop. First, we are naming the loops. So there are two independent loops, and assume that the two independent loop currents are I1 and I2, and the branches are named as A, B, C, D, E, F. How the loop analysis or mesh analysis can be done means we have to apply KVL to the available loops and we have to write the loop equations. So apply KVL to each loop and form the loop equations. So if you apply KVL to the first loop, the loop equation is 3 into I1 plus 5 into I1 minus I2 plus 6 into I1 is equal to 50. You see here the voltage 50 volt is a rise and the remaining voltages are drop. So all the drops are added together, which is equated to rise in voltage. So if you simplify this equation, we will get the final equation as 14I1 minus I2 is equal to 50. Consider this as equation 1. And if you apply KVL to the loop 2, then it will be 2I2 plus 8I2 plus 5 into I2 minus I1 is equal to minus 25, because through 5 ohm resistor current I2 and I1 are flowing in the opposite direction, so the current is taken as I2 minus I1, and the voltage is considered from positive terminal to negative terminal, so it is taken as minus 25. So the final equation is minus 5I1 plus 15I2 is equal to minus 25. So consider this equation as 2. Now we are going to solve these two simultaneous equations for the values of I1 and I2. So this can be solved using simultaneous equation method, or we can arrange these two equations in the matrix form and we can easily solve these equations using Cramer's rule. So arrange the two equations in matrix form. So now the matrix will be like this. So the matrix should be taken in the form as R into I is equal to V. So here this is R11, R12, R21 and R22. You see, this will be the resistances available in the sum of the resistances available in the first loop, and this will be the sum of the resistances available in the second loop, and these two will be equal value, which is the common element between loop 1 and loop 2. You see, this is loop 1. Here the sum of resistances will be 3, 5 plus 6, and the sum of the resistance in the loop 2 will be 5 plus 2 plus 8, and the common element between the two loops is 5, which can be taken as 5, and the value should be minus or plus. Here the two loop currents flowing in the opposite direction through 5 ohm resistor, so it will be minus 5, and otherwise we can form the equations using these two equations. You see, here the coefficient of I1 is 14 and coefficient of I2 is minus 5, and here the coefficient of I1 is minus 5 and coefficient of I2 is 15. So this matrix will be 14 minus 5 minus 5 15, and here there are two loop currents, so this will be I1 I2, and this is the voltage uh, voltage equation, voltage value. So here the voltage value is 50 and here it is minus 25, so this will be equal to 50 minus 25. Now we are going to solve this equation using Cramer's rule. So first find the value of delta, that is a determinant of the matrix. So the determinant for a 2 by 2 matrix can be calculated as 14 minus 5 minus 5 15, and if you cross multiply this 14 into 15, that is how the matrix determinant is calculated means 14 into 15 minus 5 into 5. So the value is 185. Then we have to find out del I1. So if you want to find del I1, then the first column in determinant should be replaced by the column value of voltage vector, that is 50 minus 25. If you calculate this value, the value will be 625. Similarly, we have to calculate del I2 by replacing the voltage vector in the second column of the del. So we can have the value as minus 100. So using del I1 and del I2, we can calculate I1 and I2 as I1 is equal to del I1 by del, which is equal to 625 by 185, which is 3.3784 ampere. In a similar way, I2 can be calculated as del I2 by del, which is equal to minus 100 by 185, that is minus 0.541 ampere. But in this problem, we are asked to calculate all the branch currents. So the branch current IAB, you see, this is the branch AB. The branch current IAB is equal to I1, and similarly the branch current BE will be equal to minus I2, and the branch current through 6 ohm is I1 and 8 ohm is minus I2, and the current through 5 ohm is, that is branch current IBC will be the difference between I1 and I2. So the values are IAB is equal to 3.378 ampere, IEB is equal to minus I2, which is 0.541 ampere, and IBC is equal to I1 minus I2, which is 3.3784 minus 0.541, which is 3.9194 ampere. And again you have to calculate the voltage across 5 ohm. So the voltage can be calculated as resistance into current flowing through that resistance. So the value of resistance is 5 ohm and current is IBC. So if you multiply these two values, we have 19.597 volt. So I hope all of you understood the mesh analysis method and how it is used to calculate all the currents flowing through the circuit. Thank you.